Oh, crap, the lighting. No, no, no. Alright, whatever. Okay, Mr. Hello. So now we're talking about our Unit 8 video. And can't believe we're already on Unit 8. That's crazy. Like, there's like, what, like 4 more chapters or 5 within the school year? And then we're done with Algebra 2? That's crazy. And let's just get this thing on the road for our Unit 8 so we can have this, this little, what was it? The celebration. Not a party, but a celebration. Okay. So the first thing we're going to talk about is summation notations, arithmetic sum, and geometric sum, how they all relate to each other. So the first thing you want to do is you have your sub notation equation. Now first you must know what everything means. So for your I, that's your beginning. With your I, this is what you're going to put for the first formula, or for the first equation. And then the 4 right here, which is actually your n, it's just telling you what you're going up to. And the e, which is your sigma, it actually means the sum of. So, for example, here's our equation.
Did you eat my shrimp?
What?
My shrimp. Did you eat my shrimp?
You know, you always have a good time coming.
Did you eat my shrimp?
No. Why did I eat your
you did. It wasn't Lucky. Was it the dog?
Prove it.
How can I prove it if it's eating?
Will you shut the hell up? I'm trying to do this video.
Do it in the dark.
God, you so childish. Jesus, got me messed up. Patrick. God, you annoying. I'm gonna have someone kick his ass one day. Alright, sorry for that interruption. Where were we? Okay, so we're talking about summation notation. Okay, so now once you have your I, you'll plug into this equation and you will go up to 4. So you have 2 parentheses, 2 times 1 plus 1, 2 times 2 plus 1, 2 times 3 plus 1, 2 times 4 plus 1. And once you simplify and simplify, this will be your equation. Or this will be your once you start simplifying, I forgot to simplify even further. So 8, let's see. So that's 16, 16 plus 8. Alright, so that equals to 24. Okay, so now we want to talk about the arithmetic sum and geometric sum and how they relate to each other and whatnot. So for our geometric sum, see, you will use your geometric sum and geometric sum, which is basically also your series, is when you have the addition sign right here. Now the difference between geometric and arithmetic series is arithmetic series when you're adding. So for right here, it's like you could tell it's plus 2 plus 2 plus 2. And for your geometric, that's when it's basically multiplication. So it'll be like 3 plus 6 plus 12 and then plus 24. You can tell that's multiplying even though it has the addition sign right here. And that would be when you use those. So the difference is arithmetic is addition and geometric is multiplication. Okay, so let's talk more about the arithmetic series and the geometric series. Now here's our equation. So like I said, arithmetic series for you, if you have the addition. So our equation for the arithmetic series would be Sn, which is your sum of terms, plus n, which is your number of terms, and then A1, which is your first term, and then An, which is your last term, divided by 2. In our geometric series, our equation is Sn, which again is sum of terms. And now this time, it will be A1, your first term, 1 minus R, which is your common ratio, and then your N, which is your number term, minus 1 minus R, which is your ratio. Okay, so let's put the arithmetic series to work. So here we have the arithmetic series, the equation, and let's use our numbers from our previous equation. 3, 5, oh, I'm sorry. 3 plus 5 plus 7 plus 9. Okay, so now you want to find the sum of all these terms. Yes, so you want to find the sum of all these terms, which you can do in your head, but let's do, we're having like bigger numbers. So you just put them inside the equation, n, which is your number of terms, for a1, your first term, an, your last term, over 2. And once you simplify, you will get that the sum of all these terms are, or is, 24. Okay, so let's start talking about geometric series. Now our geometric series, remember it was, if the multiplication, you can see if there's going by 2 times 2. So this equation is much different. So it'll be your a1, remember, you just input all the numbers. So a1, your first term is 3. 1 minus your ratio, which is 2, over number of terms, 1, 2, 3, 4, 5, 5. And then 1 minus 2 for your r. And once you simplify and all that, you will get that the sum of this geometric series is 93. Okay, so let's start talking about something a little different, arithmetic sequence. Now, arithmetic sequence, when you have a comma instead of addition, you have the addition signs, you have comma signs, and you can tell if it's going by addition or multiplication. So addition, you can tell it's going by 2. So in this type of equation, you want to find the next one or the one further. So this way you want to find your 7th term. Now here's the equation, an, which is your n, which is your number of term, plus a1, your first term, plus parentheses n, your number of terms, minus 1, parentheses, let me close parentheses, d, times d. Now d is your, what you're going by. In this case, we're going by 2. So you'll plug everything in, 3 plus parentheses 7, minus 1, close parentheses, times 2. And once you do all the simplifying, you will get that your 7th term will equal to 15. Okay, so now let's talk about the geometric sequence. Now, the geometric sequence is different from the arithmetic sequence is because now you're multiplying and not adding like the other one was. So here you have 2, 6, 18, 54. Now, you want to find what's your 8th term. Now, you have, now here's the equation. an equals a1, and an is the total number of terms. a1, your first term. Parentheses r, and your r is what you're going by, your common ratio, which is 3. And your number of term minus 1. So here's your equation. So it would be a of 8 equals 2, parentheses, 8 to the 8th power minus 1. So once you finish simplifying and all that, you will find that your 8th term will be 4,374. Okay, so let's say if you have a sequence that's like 1, 5, 7, 10, and then 50. Now, this would neither be geometric nor arithmetic because it doesn't have a pattern. Like you can't multiply it, it won't equal out. So basically it'll just be neither. Your answer would be neither and you'll just leave it alone. Okay, so now we're going to be talking about pyramid Sleeza. So here's our question. Explain how you calculate how many rounds it would take for the entire U.S. population of 300 million people to join a pyramid scheme if it started with 3 new recruits and each recruit had to recruit 3 members at each time. At the 17th round, what percent did this represent of the total number of recruits? This is our geometric series because you have 3 recruits and each recruit recruits 3 more people. So it'll be 3, 9, 27, 81, 243, 729. And we're trying to find the 17th term, which is, well, in this case, the round. So you know it'll be your geometric sequence because you're going by 3, you're multiplying by 3. So you will input your SN, which you would know is 300 million, equals 3. Your starting number, minus 1. 1 minus r, which is because we're going by 3. But we don't know our n. We're trying to solve for that. So if you want to solve for n, the first thing you want to do, you want to divide by 3. And then you would, and then you want to get rid of the 2, negative 2. So you'll multiply by -2, because what we gotta do is one side, gotta do to the other in order to cross that out. Yes. So now you have 1 minus 3n, and you want to get rid of the 1. So you would divide by -1, both sides, and you will get you'll subtract. Yes. No, you will add a 1. So then now your final equation, or not your final one, you have 200 million and 1 equals 3n. Now from here, you will want to put into log-based formula, because now you have the log-based formula basically. So now you would do log 3, because your log, whatever is right here, you will put for your logs, and whatever is on this side, which is your equaling to, would be your top number. So your log base 3, 200 million equals n, and you will put whatever your higher number is will go on top, whatever your lower number is go on the bottom. So now we have our trusty calculator. Make sure everything is correct. So log of divided by your log of 3. And you'll get 17.39, which you round it, you'll be 17.4. So your n, which is number of rounds, will be 17.4 rounds. So it takes 17.4 rounds to take up the entire U.S. population. Okay, so now we're trying to find the percent. So now we solved for n, so which was 3 to 17, which equals to 129,140 and 140,163. So now we want to find the total number of people who are actually in that round. Actually in the round that you're going to be joining, supposedly other than the people who are actually in the 17th round. So now you have your SNA, you will put in geometric sequence because multiplying. So once you finish doing that and you're simplifying, you would get 193,710,243. Now you will divide these two numbers by each other. This number divided by that number. That way you can find your actual percent. And once you finish doing that, you will get 66.7%. Now that's a pretty high percent, which is bad. So I would not join that pyramid scheme. Miss Lisa. Okay, so let's talk about stacking apples and how to find the number of apples and the number of apples in a specific row using the sum of square and sum notation. So here you have an equation. There's 3 layers of apples, and the layers are 1 apple and then 4 apples and 9 apples. This pattern continues for 15 apples. Now let's say we just want to find the total number of apples in this whole pyramid. You'll use the sum of square formula, which is n parentheses n plus 1 parentheses 2n plus 1 over 6. And their n is your number of rows, so 15. So then once you put that in, 15 times 16 times 31 divided by 6. And then once you finish simplifying, you would have 1,240 apples inside, total number of apples inside that pyramid of apples. Okay, so let's figure out how to do the same thing, except we're going to use sub notation. So here you have your sub notation. Remember, this sigma is your sum. So you start off with your I, which will be 1, and then your total number, which was 15 rows. So then I guess we'll use I squared because they gave us that the first one was 1, The second one was 4, the fourth row, and then the third row was 9. And I square is the only one that can be put inside here. So 1 square plus 2 square plus 3 square plus 4 square dot dot dot. All the way up until 15 square, which is your total. Now it says it wants us to find the total number of all these numbers. Now you can do that by hand, or you can get your trusty calculator and you just got to keep on going. I love that song. $14 square. And there you have it. The exact same answer we got for the last time. So once you do this, you would get that the total number of apples is 1,240 apples. Now we can still use this formula to figure out basically anything. So let's say if we want to figure out how many number of apples is in the 225th row. So we'll just do your I, which will be 225. You just square that, and that will get you 225 squared. That'll get you 50,625 apples in the 225th staircase, or the 225th row. And that will be that for the stacking of apples at the Vons store. Okay. So let's talk about good old retirement. Yay! So now we have an equation. On January 1st, you deposit $6,000 in an retirement account that pays 17% annual interest. You make this deposit on January 1st for the next 32 years. How much money do you have in your account immediately after you make the last deposit? So you want to find, and now we're trying to figure out the total amount of money after 32 years. So the first thing you want to do, you want to figure out, because since it's a 7% interest rate, first thing you want to do is figure out what the next year be. And that's will be this, and then your next year, because you multiply this by 0.07, not this one. And you just keep on going, but you want to keep on going to the 32nd year. Now, instead of figuring all this out, there's the simple equation, which we'll be using our geometric series. And this will help us figure out how much money we would have after the 32nd year. So once you input the numbers, your A1, your first number, your 1 minus your R, which you're going by, which is 0.07. Yes. So once you simplify everything, you finally get to 32 years, you have $661,000, $661,308.93 in your final account. Okay, so now we're trying to figure out, or for A to B, we're trying to figure out how much was added to your retirement account just in the last year, from the 31st year to the 32nd year. Now we just do the same geometric series, but except for having 32 be our N, it'll be 31. And you'll get $612,438.25. Now you would subtract from our previous one, which is the 32 year first minus the 31st year, and you would get 48,868 cents. And this will be the total amount that you just got in the last year. Now remember, the first time all you did was deposit $6,000. And just in this last year, from 32 years on 31 years, you got $48,870 $1.68. That's a lot of money. Okay, so for 8C, it tells us write a recursive rule for how much gets added to your bank account every year. Now this would be the rule. Your AN minus 1. So your total number of years minus 1 times the point 1.07. And this is because that's your interest rate, which is 7%, and times the 6,000, because remember you put that in there each year. So this would just be your simple rule that you will have for number 8C. Okay. So finally, it wants us to say explain when your account grows the most and why. Now here's my answer. The interest is greater because you input a lot more money, and the account grows more each year because it gains more compound interest as the years continue on and on and on. So this is how we do our retirement, and today we have learned a good retirement plan, a good stacking apples, a pyramid scheme, geometric sequence, arithmetic sequence, and series, and whether it can be neither. And that was it for this lesson in sub notations. So, Mr. Suhu, thank you very much for watching my video, and have a lovely day. Oh yeah, and I hope everyone did their video.